Hi everybody, welcome again. This is Jim Corkins and we are doing 2.0a tutorial and I'm going to show you how to do it. Okay, so here we go. The first page has problems that look like this, and I'm going to show you a sample of where you're doing vector addition of two vectors. Again, it's just like the it's just like the one-dimensional vector addition in 1.3. However, so you're playing that same thing where you're going to take a look at the operation and take a look at the vectors you're given, and you have to solve for whatever you're not given. In this case, r, and then we have to figure out the length of r, and we're going to be using Pythagorean's theorem to do that. So here we go. We're given j and p, and those are both the positive directions of those. So let's just start out with the p vector, and we're going to add to that j. So p looks like it's pointing down and to the right. Was it 1, 2, 3, 4? So this is 1, 2, 3, 4. So that's the p vector. The j vector looks like it's pointing down and to the left 2 points. So this is the j vector. And you don't have to do Pythagorean's theorem every time. If you do have it aligned to the coordinate system, just go ahead and just count that out, right? So in this case, when you add these two vectors together, they are going to be pointing straight down a total of 1, 2, 3, 4, 5, 6. So that's going to be -6. Well, the length is, we just want the length, which is just 6, right? If we wanted the actual vector r, we would put -6, right? But since you might not have something so convenient for you, well, let's go ahead and do Pythagorean's theorem, okay? So to do it with 2 dimensions is a little bit more intensive. Notice that we have a positive p in the x direction, which is equal to +2, and we have a p in the y direction, which is 1, 2, 3, 4. So that's -4. In the x direction, we have a j in the x direction that is -6, and we have a j in the y direction that is -2. So those are going to be important to figuring out the total hypotenuse of this. Okay, so to find r is going to be equal to the total direction in the x direction, which this is going to be silly, but we're gonna take the px vector and add it to the jx vector, and that'll be the square. You have to take the x direction components and the y direction components, and then we're going to add that to the y direction components of py plus j y, and then we're going to square this. So we're doing c squared equals a squared plus b squared. So when we do this, the px vector is +2, but the jx vector is -2. I don't know why I put a 6 there. That should be -2. So this is going to be -2. And we're going to square that, which that's just 0. And we're going to add this to the y direction vector. So notice the reason why this is only pointing down is because those two subtract, so it's reflected right here. In the x direction, in the y direction for p, you have a -4 and you have a -2. So we're going to add those together, really the negatives. So what we're going to end up with is r is going to be equal to the square root of 0 squared plus a negative 6 squared, which is going to be equal to the square root of 6 squared, which is just 6. So r is going to be equal to 6. And notice when you're squaring and square rooting, it rips off the actual vector direction, so now you have the length. And then you would have to add the direction of that vector later on. But since we're only asking for the length here, that's what you get. Okay? Now, here we go. In this case, we're going to have to do a couple things. We need to find f. All right, so this one is one of the more complicated ones. The ones that you have to do for your tutorial are easier. They're more similar to this, which I think is good enough. But let's go ahead and try this. In this case, we're given u and z, and we need to figure out the length of f, but we're given this operation. Okay, so we have to first manipulate the operator. U is going to be black. We have to subtract the 2z from it, and that is going to be equal to our 3f. And so let's go ahead. Eventually what we are going to do is we're going to go ahead and figure out the length of that, and then we'll divide it by 3. So I'll show you what I'm saying. So let's do this part first. Let's take u, and then we're going to reverse the z and then add 2 of those vectors to it. So here's what I'm saying. So the u vector looks like it's pointing to the right. What is that? 1, 2, 3, 4, 5. So that's ux is equal to positive 5, and down 2. Actually, that looks like it's 6. So 6, and then down 2. This is looking terrible. So it's 1, 2, 3, 4, 5, 6. So it's plus 6 in the x direction, and in the y direction it looks like it's pointing down 2. So I'm going to draw that vector. 1, oops. So 1, 2, 3, 4, 5, 6. Actually, I should probably do it over here. 1, 2, 3, 4, 5, 6, and then down 2. So this is the u vector in the x direction. This is just the u vector. Okay. Now we're going to add the 2 of the z vectors. Now the z vector is pointing down and to the left, so a negative z vector has to be pointing up and to the right. So we need 1 of those. So this is negative z, and 2 of those. Negative z. So, in other words, the 3f vector is pointing up and to the right. Okay? So, this is 3f vector. That is this. Okay? So, once we have that established, we're going to have to divide that by 3. We're going to have to divide whatever components of this by 3. Okay? And we did this one more difficult way. Let's do the 3f vector in easier way. So we only need the 3f vector. And this 3f vector is pointing to the right this distance. You know what? I'll make it easier on ourselves. This 3f vector, it's pointing up 2, and it's pointing to the right this distance. So this 3f vector the y components of that are here, which is going to equal to positive 2, and the 3f vector in the x direction is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's pointing to the right 10. So one way to do it is to do all this business right here. Another way to do it, which I think is a smarter way, is just calculate this. Okay, so to figure out 3f, the length of 3f, we're going to take, so that the length of 3f vector is going to be equal to the 3f vector in the x direction squared plus the 3f vector in the y direction squared. So the 3f vector is going to be equal to the square root, okay, of the 3f vector in the x direction, which is 10, so positive 10, that we're going to square. And in the y direction, the 3f vector is positive 2, that we're going to square. So this is going to be the square root of 104. And so the 3f vector length is going to be 104. We're going to square root that right here. So 10.2. So this is the 3f vector, which is equal to 10.2. Now to find out what the f vector is equal to, so we know this is equal to 10.2. Now to find out what f is, we're going to take 10.2 and divide it by 3. So whatever 10.2 is divided by 3 equals 3.4. So this is going to be 3.4. And if I was going to do this, if I was you guys, I would do it this way, right? This one, obviously, I wouldn't have gone through all of this. I would just write that straight down and call it 6. But this one, whenever you're given, figure out the vector that you have, go ahead and then break that hypotenuse vector. Don't do the addition of the other two sides. Don't do like the ux and negative zx squared plus uy plus the negative zy squared, and don't do it this way. I would do it this way, right? Once you get that hypotenuse, that 3f vector, take the components of that vector and figure out that length using Pythagorean's theorem. And then in this case, we have to divide it by 3. Okay? So that's the first page. Like I said, yours is a lot easier. But there is this second page. Okay? And this is one of the ones in there. So let's go ahead and get started. Here, we're supposed to find z. We're also supposed to find the angle theta. And we're supposed to perform this operation. So let's first of all, let's manipulate our thing first. So to find z here, you got to subtract both sides by, we'll call this 3j, and we have to subtract both sides by negative b, and then this is going to be equal to our z vector plus u, and then we're going to subtract the u vector onto that other side too. So 3j minus b minus u, that is going to be equal to z. So we're going to take 3 of these j vectors. Well, first of all, let's go ahead and reverse our b vector. Our b vector is pointing up, so our negative b vector needs to be pointing down. And our u vector is pointing up and to the right, so the negative u vector has to be pointing down and to the left. That looks parallel, so that's negative u. Okay, so let's take 3 of the j vectors, which is down and to the right too. So I'm going to start up here. Since I'm going to be going down more, I'm going to start really high up here, and we're going to be going to the left a lot, so start where it's easier. So the j vector, we're going to take 3 of these. There's 1. There's 2. And there's 3. And then this u vector looks like it's pointing 1, 2, 3, 4, 5, 6 down. And, so it's down 2, but shoot, let me just double check this. This u vector should be pointing looks like it's down 2. So that should be the u vector. So it looks like it's pointing 1, 2, 3, 4, 5, 6 to the left. So I'm going to take this 6 to the left. 1, 2, 3, 4, 5, 6. And then down 2. So this is the u vector. And this is the 3j vector. So that's the negative u vector. Now we got to do the b vector, which is 1, 2, 3, 4, 5, 6. So this is going to be 1, 2, 3, 4, 5, 6. And so that's negative b. I like the 3 vectors because it makes you really strong at doing your vector addition and your trigonometry as well. Okay, so the z vector, which we're going to use purple, and we're only going to do our trigonometry on this. This is pointing down, whoops, this is pointing down and to the left, this distance right here. So we have to count that. That's going to be this distance down. So that's 2, 4. So 2, 4, 6, 8, 10, 12, 14. So the z in the y direction is negative 14. And this is z. And in the x direction, it's going to be this distance. Which looks terrible. Let's try this again. Okay, so in the x direction, it's 2, 4, 6, 8, 10, 12. So z in the x direction is negative 12. Okay. So with the x direction coordinate, there's 2, for the angle theta that they want, you could use this as your theta because it has to make an angle to the horizontal as asked in the problem. Okay. So in this problem, the fourth vector and their angle relative to the horizontal x-axis. So that could be theta or this could be theta. They will be the same angle. Okay. So let's do it together. Let's figure out this. So the z direction guy, so the length of this z vector right here, this is our z vector length. And we need to figure out that total direction, the total length of that hypotenuse. So that z vector is going to be c squared, which is going to be equal to a squared plus b squared. So we're going to square root both sides. And when we do that, you're going to get a length. So we're going to go ahead, so that's negative 12 that we're going to square for the x direction. And the y direction is negative 14. When you square those will just be positive numbers. So the length of z is going to be equal to, let's go ahead and figure it out. So that's 14 that we're going to square plus 144 for 12, right? So let me do that again. We're squaring the 14, and so we're going to add that to the square of 12. Which is 340, and we're going to square root that. So 18.44 is the length of z. 18.44 is the length. So this length is 18.44. Okay. Now, for the angle theta, okay, we're going to have to use tangent of theta. So I'm going to do this here first. And we don't want the directions of this. So tangent of theta is opposite over adjacent. So don't put negative 14 and 12, although they do cancel out in this particular case. We don't want to do that. We just want to put 14 and 12. We don't want the directions of the vectors and complicate it. So the inverse tangent of 14 divided by 12 is what we're going to do. So 14 divided by 12, and then we're going to take the inverse tangent of that. 49.3, so 49.4. So 49.40. So this is 49.40, and this is also 49.40. So 49.40. Okay. And so that's how to do 2.0 tutorial. Okay. I hope you have a good time with this.